Welcome to Study Loop.
This is the answer to Chapter 13, problem number 41 from the Smith Organic Chemistry textbook. And so this problem presents us with morphine, heroin, and oxycodone, which are very strong, very addictive narcotic analgesics and are often drugs of abuse. And so we're asked, how could IR spectroscopy be used to distinguish these three compounds from each other? And so I didn't redraw these molecules because they're pretty complex molecules. And really, we just need to talk about what's different between each molecule. And so this is going to come down to carbon double bond oxygen IR peaks and alcohol peaks. So when we look at morphine, morphine has two alcohols in it. So we're going to see the OH stretch between 3200 and 3600 wave numbers. So 32 to 36 wave number. But one thing we don't see is the carbon double bond oxygen stretch. So no carbon double bond oxygen, which would be at about 1700, but we don't see it. It's not there. So then looking at heroin next, heroin is going to have that carbon double bond oxygen stretch. And so that's going to be at about 1700 wave numbers. But we do not see the alcohol stretch. So there's going to be no peak between 3200 and 3600. And then lastly, looking at oxycodone, oxycodone has both. So we'll get the carbon double bond oxygen at about 1700 wave numbers. And we'll also get the OH stretch between 3200 and 3600 wave numbers. And so basically, this is how we tell, right? If we see an alcohol stretch but no carbonyl, then we have morphine. If we see a carbonyl but no alcohol, then we have heroin. And if we see both the carbonyl and the alcohol, then we have oxycodone. And of course, it's not that simple, but if we knew or strongly suspected that what we had was one of these three molecules, this is a way that IR could distinguish between these three. Obviously, there are an unlimited number of molecules in the world that have carbonyls and oxygens, or one or the other. But if we know that we have one of these three molecules, we can put it in an IR, and this is how we could tell which of these three it is. And so that's the way to approach this problem. We really just need to look at what's different and what's going to give us good IR peaks. And in this case, it's the alcohols and the carbonyls. And so that's the answer to chapter 13, problem number 41.